So from the previous class, it is amply clear that the two molecular orbitals are possible by ethylene molecules. Two molecular orbitals are possible. Out of the two molecular orbitals, the one is the pi and another molecular orbital is pi star. And by combining these two molecular orbitals of ethylene molecules, we are going to construct the molecular orbitals of 1,3-butadiene. In fact, 4 molecular orbitals of 1,3-butadiene. Why 4? Already I have explained in the previous class. And the possible combinations with pi and pi star are 6. Out of those 6, we have removed the 2 combinations which are pi with positive pi, pi with the positive pi star and pi with negative pi star. What is the reason? I have explained clearly in the previous video. The possible combinations are hence pi with positive pi, pi with negative pi, pi star with positive pi star with negative pi star. Now let us draw those 4 molecular orbitals for 1,3-butadiene. So coming to the first one, what is that? Pi positive pi, pi positive pi, pi positive pi. 1, 2, 3, and 4. Right. Pi means this is the pi. That is 2 lobes are at the top face and the 2 lobes are at the bottom face. Right. 2 lobes are at the top face and 2 lobes are at the bottom face. Now let us try to fill the sign of the lower lobes later on. So pi with positive pi, right? So pi with positive pi means, so we have to add with the same pi again. So that is positive and positive. Right. Now coming to the lower lobes. If the upper top lobe is positive, the lower lobe will be negative. Upper lobe is positive, lower lobe is negative. Upper lobe is positive, lower lobe is negative. Upper lobe is positive, lower lobe is negative. So this is pi with positive pi. Now in this pi with positive pi, there are no nodes. What do you mean by node? Node is a plane where the wave function changes its phase. Plane where wave function changes its phase, right? Now here there is no node, positive, 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 positive. So number of nodes in this are 0. Number of nodes in this are 0, right? Now coming to this, whether it is the bonding molecular orbital or anti-bonding molecular orbital, we have to look at it, right? So it is bonding because positive, 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 bonding, positive, positive, bonding, positive, positive, bonding. So 3 bondings are there, hence it is 3 bonds, right? So this is bonding, this is bonding, this is bonding. So 3 bondings are there. Since 3 bondings are there in this particular molecular orbital of 1,3-butadiene, it is bonding molecular orbital. It is bonding molecular orbital. Right. We are coming to the next molecular orbital. What is the next combination? Pi with negative pi, pi with negative pi, pi with negative pi. These are the lobes we have to draw. Don't be confused. Right. Now, pi. What is pi? The top lobes are positive. Bottom lobes are negative. Now it is negative pi. Since it is negative pi, what we need to do? We have to write exactly reverse of the pi. We have to write exactly a reverse of the pi. Right. So it is positive, so this will be the negative, and is positive, this will be the negative. Got it? Pi with negative pi means we have to reverse it, that's it. Both are positive, so definitely both will be the negative one. So that is what we have to do. Now we have to fill the lower lobes. Now it is positive. Since it is positive, the lower lobe will be negative. Upper lobe is positive, the lower lobe is negative. Upper lobe is negative, the lower lobe is positive. Upper lobe is negative, the lower lobe is positive. Right. Now let us find out whether the nodes are there in this or not. Right. So we have to focus on the nodes, because based upon the nodes only we can construct the molecular orbital energy diagram of any of the molecule. Right. So whether the nodes are there in this. So if you see the nodes, here there is no node, positive, positive, no node. But here it is positive I negative. Since it is positive I negative, there is a node over here. There is a node over here, right? And coming to here, negative, negative, both are at the bottom face, bottom at the bottom face. So there is no node. So number of nodes in pi, negative pi is, number of nodes is 1. Number of nodes is 1. I hope it is clear, right? Positive, positive, no node. Positive, negative, there is a node. Negative, negative, both are at the bottom face, no node. So number of nodes are 1. Now the question is whether it is bonding molecular orbital or anti-bonding molecular orbital. We have to look at it. Right. So this is positive, positive, bonding, right? Bonding. Right. This is a positive, negative, anti-bonding, negative, negative, bonding. So how many bondings are there in this? How many bonds are there in this? 2 bondings are there. So 2 bondings are there minus 1 anti-bonding is there. 1 anti-bonding is there. 1 anti-bonding results in the formation of what? 1 bonding. 1 bonding. Since it contains one bonding, we can say that it is the bonding molecular orbital only. It is pi, negative pi is the bonding molecular orbital. So coming to the next combination. What is the next combination? Pi star with positive pi star, right? So let us see about this molecular orbital. Pi star with the positive pi star. So it's very simple to draw, but by seeing these lobes you will become panic, but no need to be panic. It's very simple to understand. Pi star with positive pi. What is pi star? Pi star means positive I negative. Positive I negative. The lower lapping is very less. This is the pi star, right? So first let us write the pi star. Pi star, right? So positive, right, and it is negative, right? Negative. So let us fill the upper lobes first. Now pi star with positive pi star, right? Pi star with positive pi star means what we have to do? We have to combine the pi star with the pi star, right? So we have to combine. So what is the pi star? What is the pi star? We have to write the pi star only. So positive and negative. Got it? I hope you got it. Pi star, what is positive? Pi star, positive, negative. Positive, negative. Just let us focus only on the one lobe. So if you focus on the one lobe, the other lobe can be easily filled, right? If one lobe is positive, other lobe is negative. If now one lobe is negative, other lobe is positive, right? Now, pi star with pi star, in this, it is positive, it is negative. As we are combining with the same pi star, definitely it will be the same, positive and negative. Now let us focus on the number of nodes in it. Number of nodes in it. Number of nodes in it. Now number of nodes, let us see the number of nodes. So positive and negative, the wave function has been changed. Wave function has been changed. Negative, positive, the wave function has been changed. Positive, negative, the wave function has been changed its sign. So number of nodes in this particular pi star with positive pi star are 3. Number of nodes are 3. Now let us decide whether it is bonding molecular orbital or anti-bonding molecular. That is also important, right? Right. Now coming to, let us discuss. So positive and negative. positive negative, it is anti-bonding. Negative positive, anti-bonding. Positive negative, anti-bonding. Positive negative, anti-bonding. So how many anti-bondings are there? This is anti-bonding, this is anti-bonding, this is anti-bonding, right? This is anti-bonding. So 3 anti-bondings are there in this. Since 3 anti-bondings are there in this, we can say that pi star with positive pi star combination is anti-bonding molecular orbital. Anti-bonding molecular orbital. Right. Just give me a second. Now let us draw the another possible combination. What is that? What is that? What is the last combination? Pi star with the negative pi star. Pi star with negative pi star. Right? So let us draw the lobes. 1, 2, 3, and 4. Pi star. What is pi star? Positive, negative, positive, negative. Let us write it with the red pen so that it will not be confused. Positive, negative, right? So now it is negative pi star. Negative pi star means what? It will be exactly reverse to the pi star, right? If exactly reverse to the pi star. Since it is exactly reverse to the pi star, if it is positive, it will be negative, right? If it will be negative, and this will be the positive. This will be the positive. This will be the positive, right? Positive, negative, negative, positive, right? Now we have to fill the lower lobes, right? So if this is a positive, this is negative, and this is negative, this is positive, and this is negative, this is positive, and this is positive, this is negative. Negative. Now let us see the number of nodes presented. Why I am emphasizing on the nodes is you will come to know what is the significance of this nodes while constructing the molecular orbital energy diagram of 1,3-butadiene. Now, nodes, positive, negative, it is anti-bonding. First let us focus on the nodes, right? So positive, negative, the sign has been changed. This is one node. Negative, negative, there is no node. Negative, positive, there is a node. So number of nodes in this pi star, negative pi star are 2. Now we have to decide whether it is the bonding molecular orbital or anti-bonding molecular orbital. So let us decide that. So now it is anti-bonding, it is bonding, it is anti-bonding. So it is the combination of 2 anti-bondings minus 1 bonding. So results in the formation of 1 anti-bonding. Right? So hence we can say that pi star, negative pi star is also anti-bonding molecular orbital. Right? Yep. Just I will remove this. Right. So I have not filled the lower lobes for this pi star, positive pi star. If it is positive, it is negative. If it is negative, it is positive. If it is positive, the lower lobe will be negative. And if the upper lobe is negative, the lower lobe is positive. Right. Now, so number of nodes for pi with positive pi molecular orbital is 0. While coming to the pi negative pi, the number of node is 1. And while coming to the pi star with positive pi star molecular orbital, the number of nodes are 3. And coming back to our pi star, negative pi star, the number of nodes are 2. Right. So based upon this number of nodes only, we are going to construct the molecular orbital energy diagram for this particular 1,3-butadiene. Is this clear? Node is 0 for positive pi with positive pi. Node is 1 for pi negative pi. Node is 3 for pi star positive pi star. Node is 2 for pi star negative pi star. Now why I am explaining or emphasizing much on the node is node is directly proportional to energy. Node is directly proportional to energy, and as we know that the stability or energy is inversely proportional to the stability, as a node is directly proportional to energy, it is inversely proportional to stability, right? So node is inversely proportional to stability. This is very important, students. Number of nodes decides the energy level of each and every molecular orbital of any of the molecule, whether it is 1,3-butadiene or benzene or nitrogen or fluorine, whatever it is. Number of node decides its energy level, right? So do remember that node is directly proportional to energy, and as the energy is inversely proportional to the stability, and as a node is directly proportional to energy, node is inversely proportional to stability. Right? I hope you understood this concept. Node is directly proportional to energy. Right? So in 1,3-butadiene, how many p electrons are there? How many p electrons are there? So 4 atomic orbitals, 4 molecular orbitals, hence 4 p electrons. 1, 2, 3, and 4 p electrons. Right? Now let us try to accommodate these 4 p electrons in the 4 molecular orbitals if possible, right? So out of the 4 molecular orbital, let us say that the first one is psi1 and the second one is psi2, and still remember that this is non-bonding line. This is non-bonding line, and above the non-bonding line, whatever the molecular orbitals are present, they are bonding molecular orbitals. This is same for all the molecules. Below the non-bonding line, whatever the molecular orbitals are present, they are bonding molecular orbitals, and whatever the molecular orbitals which are present above the non-bonding line are anti-bonding molecular orbitals. So anti-bonding, as they are above the non-bonding line. Now let us say that this is psi3, this is psi4. So psi1 is the first molecular orbital, psi2 is the second molecular orbital, psi3 is the third molecular orbital, psi4 is the fourth molecular orbital. Right. Now we have 4 molecular orbitals, right? So since we are having the 4 molecular orbitals, which will be the psi1? Which will be the psi1 in this? Pi with positive pi, because as we move up, what will happen to the energy? As we move up, what will happen to the energy? Energy will increase. Energy will increase. Now the psi1 is it is at the bottom of this. At the bottom of this. Bottom of this means what? At the lower energy level. Lower energy level. And as the node is directly proportional to energy, we can say that this molecular orbital is pi positive pi. Positive pi. As we move up, what will happen to the energy? Energy will increase. And as the node is directly proportional to energy, what will happen when we are moving from bottom to the top? Energy will increase. Energy will increase. The number of nodes also will increase. So number of nodes for the second molecular orbital is 1. So for the first molecular orbital is 0. For the second molecular orbital is 1. What is that molecular orbital with the node 1? We have discussed pi with negative pi. right? Pi with negative pi. So for the pi with negative pi, the number of node is 1. How we are deciding? How we are deciding the energy level of this molecular orbitals? Based upon the simple relation between the node and the energy. Node is directly proportional to energy, and as we are moving up, the energy increases, number of nodes also increases, right? Now we have talked about the bonding molecular orbitals. Now let us come to psi 3. What is the psi 3? Psi 3. Then what the number of nodes in the psi 3? The number of nodes in the psi 3 will be more than psi 2, because the energy is increasing as we are moving up, right? Energy is increasing, so the number of nodes also increase. That is, number of nodes for psi 3 are 2, right? Now what is the molecular orbital associated with the number of nodes 2? The number of nodes 2. What is that? Pi negative pi star, negative pi star. The number of nodes present in this are 2. And the last one, so definitely the number of nodes will be 3. Maximum energy will be associated with this psi 4. The number of nodes for psi 4 are 3. Right? What is that? Anti-bonding molecular orbital which comprises 3 nodes, that is pi star, positive pi star, positive pi star. Right. Now how many electrons are there? There are 4 electrons. Out of 4 electrons, 1 electron will enter into the first bonding molecular orbital, and next electron will enter into the second molecular orbital. After that, according to what? Which rule? This is according to Hund's rule, right? According to Hund's rule, the pairing does not occur or takes place until each and every orbital is filled with 1 unpaired electron. That is the Hund's rule, right? So accordingly, we are accommodating 1 electron in psi 1 and another electron in psi 2, right? Now what we have to do? We have to pair up. Right? Now psi 1 and psi 2. Now 4 electrons were a part of 1,3-butadiene, and these 4 electrons which are a part of 1,3-butadiene have been placed in the bonding molecular orbitals only. Since all the electrons of 1,3-butadiene are being placed in the bonding molecular orbitals, it is highly stable molecule. That is the reason we are studying the molecular orbital theory for 1,3-butadiene. What is the reason for studying the molecular orbital theory of 1,3-butadiene? The first reason is in order to visualize the conjugation with the help of bonding molecular orbital, anti-bonding molecular orbital, like this, right? Like this. With the help of bonding, anti-bonding, bonding, anti-bonding. So what we can reveal from this, what we can grab from this particular information about anti-bonding, bonding, anti-bonding, which information we are getting? We are getting the information about the conjugation. So with the help of the molecular orbital theory of 1,3-butadiene, we can visualize the conjugation present in it, and we can predict the stability of the molecule. And as the 4 electrons of 1,3-butadiene have been filled in bonding molecular orbitals only, and as the bonding molecular orbitals are more stable, then definitely we can say that 1,3-butadiene molecule is highly stable molecule. And why bonding molecular orbitals are more stable than anti-bonding molecular orbitals, I will discuss in the next video. Thank you.